Express each mixed radical as in entire radical form. Identify the values of the variable for which the radical represents a real number. Okay, sometimes odd symbols don't show up in your notes, so just in case you don't have these, I'll write them out again, and they're quite light. 7 square root 2 is what we have there. This is considered a mixed radical because it's a mix of a whole number out front and a radical there with a square root. An entire radical means everything's entirely under the square root. Okay, so over here on the sideboard, when we took 288, we split it into 144 and 2, this came out as a 12. So if you had to put it back in, what do you have to do to put it back under the square root? You have to square it. Good. So when you try to put this underneath, it's going to get square rooted when you put it underneath, so you have to counteract that by squaring it. So what you'll have underneath here is you'll have 7 squared now getting times by that 2. And 7 squared is 49. So we have 49 times 2. And that's equal to 98. So this is the same as the square root of 98. If you wanted to check on your calculator, you just go 7 square root 2. You don't have to use multiplication. Some people go 7 multiplied by square root 2. You don't have to. 7 square root 2 in your calculator, and then square root 98, you're going to get the same decimal. Okay? This one right here for B. A to the power of 4 times by the square root of A. It's a very similar question. It just has variables. So when we go to put this guy underneath, same thing. We have to counteract the square root that is going to happen over top of him by squaring him. Okay? So it's going to look like the following. Just going to take this guy here for those people back. It's going to look like A to the power of 4 getting squared, and then there was already an A there. Okay? Power on power, what happens? Do we add those, multiply those, divide those, subtract those? Multiply those ones together. So this is really an A to the 8 times by what exponent is on that A? If we don't see it. 1, good. What do you do with those ones? Those ones get added, okay? If you ever can't remember, there's a little poster on the side over there, I think. One of those posters shows you what to do with those exponents. Okay? Okay, one thing I did forget in the question says identify the values for which of the variable for which the radical represents a real number. The first one didn't have a variable, so we didn't have to do that, but this one has a variable. So now that this is underneath here, what they're asking us is what are the restrictions on A, basically. So plus, minus, 0. Can A be positive? Yes, it gets put to the power 9, it would still be positive, and then you could square it positive. Check. Can A be negative? No, because when you put it to the power 9, it would stay negative, and you can't square root a negative, so this is a no. Can be 0. Good. Okay, so how do you describe these two items? A is greater than or equal to 0, and don't forget A is an element of reals. Okay, we always put that under there. And the last one over here was 5b, and then the 3 was a cube root. It wasn't on the b. It was the cube root of 3b squared. Okay? So these first two, in order to make them entire radicals, when we put them under a square root, we have to square them first. So these are going under a cube root, so we would have to cube them first. Okay? Now you can cube them separately or together. Lots of students see it better separately, so that's what I'm going to show. So 5 gets cubed, b gets cubed, and there was already a 3b squared under there. Okay? Others of you would have put the 5b in brackets and put the cubed on the outside, and you can distribute that cubed in because there would have been no adding and subtracting in that bracket. Okay? What's 5 cubed? Throw into your calculator. What do you get for 5 cubed? 125, good. And then you have to times that by 3. So, I'll break them out separately first. 5 cubed is 125. Then you have a b cubed. Then you have a 3. Then you have a b squared. Okay, order doesn't matter when all you're doing is multiplying and dividing. So, we don't have to multiply. We can multiply these two together and put them out front. So, you get 375 for that one. And when I say out front, I mean at the front of the rad can. So, 375. And then b to the power of not 6, because it's not power on power. You would add those, you get 5. Good. Okay, check your variable. Can b be plus, minus, or 0? Can it be positive? Yeah. Does it matter? Doesn't matter in this case. Why does it matter? Not matter. It can be anything we want because it's an odd index. You can cube root positives, you can cube root negatives, you can cube root 0. So these are all good.